The first time I saw the moon up close, really close, I expected it to feel solid. It does not. From orbit, it looks like a stone you could knock on. From the surface, it looks like dust pretending to be a stone. And from inside, if you ever got the chance to look inside, you would find something that has been quietly cracking for 4.5 billion years. Slowly, patiently, the way old bones crack when no one is watching. I want to tell you about the day that patience runs out. Not in a billion years, not in a million. Tomorrow. You are sitting somewhere on Earth right now, probably indoors, maybe near a window. I want you to picture the sky above that window, the one you have looked at your whole life without really looking. And I want you to know that the thing hanging in it is held together by less than you think. The moon is not a single solid ball. It has a crust. It has a mantle. It has a small, partly molten core. And it has scars. Old scars. Deep ones. From a time when the solar system was younger and angrier and threw rocks at everything it could reach. Most of the time, those scars hold. Tonight, in our story, they do not. Let me walk you through what happens, minute by minute. The way I watched it once in a simulation the people who study this sort of thing built, late at night, in a room that smelled like old coffee. I have looked at this one a few times now. It does not get easier. Minute 1. Somewhere in the lunar interior, along a fault line we did not know was a fault line, something gives. There is no sound, because there is no air on the moon to carry sound. But if you could put your ear to the regolith, you would feel it. A deep, slow shudder. The kind of shudder a building makes a second before it stops being a building. On Earth, in this first minute, no one notices anything. The moon looks the way the moon always looks. Half-lit. Patient. A face we have known so long we forgot it was a face at all. Minute 8. The crack reaches the surface. Not a clean line, a jagged one, running from somewhere near the Sea of Tranquility down toward the far side, the side we never see. Dust lifts off the lunar plains in slow plumes, because in 1/6 gravity, dust does not fall, it drifts, it hangs. From Earth, through a backyard telescope, an amateur astronomer in Chile notices something strange near the terminator, a shadow that should not be there. She thinks her optics are dirty. She wipes the lens. The shadow is still there. She is the first person on Earth to know. She does not know yet what she knows. Hour 1. The crack widens. The moon, for all its quiet, has been storing energy in those old scars for a very long time, and now that energy has somewhere to go. Pieces of the crust begin to separate. Not explode, separate. Slow. Almost graceful. From up here, from where I watched it, you can see the body of the moon bulging outward along the fracture, the way bread does when you tear it. Underneath, the partially molten interior begins to ooze. Not lava the way you know lava, something older, darker, pressurized for billions of years, and finally getting out. By hour 1, every observatory pointed at the night sky knows. Phones start ringing, the kind of phone calls that go to people who are not used to being woken up. Hour 6. The first chunks break free. We are not talking about small pieces. We are talking about pieces the size of countries. A fragment of the lunar crust, roughly the area of France, separates from the main body and begins to drift. Slowly at first, then less slowly. The moon's own gravity tries to pull it back. The energy of the fracture pushes it away. The two forces argue for a while. The fracture wins. That fragment is now in its own orbit. I need you to understand what that means. Stay with me here. The moon has been a single object for as long as there has been an Earth worth looking up from. Every tide you have ever seen, every poem about moonlight, every wolf in every story, every sleepless night you spent at a window, all of it was negotiated with one moon, one mass, one pull, one companion. By the end of hour 6, we have 2. By the end of day 1, we have more. The fragmentation does not happen all at once. It happens the way a windshield finishes breaking after a stone hits it. First, the impact, then the silence. Then the slow, branching, almost beautiful spread of the cracks, finding every weak point they can find. By the time the sun rises over the Pacific on the morning after, the moon is no longer a sphere. It is a cluster, a loose, drifting cluster of enormous pieces, some still touching, some pulling apart, surrounded by a halo of smaller debris that catches the sunlight like a slow-motion firework that forgot how to end. From Earth, that first morning, people walk outside and look up and see something they do not have a word for. The moon is still there. Sort of. It is brighter than it has ever been because the broken pieces are catching light from new angles, and the dust cloud around them is scattering that light in every direction. It looks, for a few hours, almost festive, like the sky put on jewelry. That one still gets me. The fact that it looks beautiful first, before anyone realizes. Then the tides start to go wrong. The moon pulls on Earth's oceans. You know this. You learned it in school, and then mostly forgot, because tides are one of those things that happen whether you remember them or not. The moon pulls the water, the Earth turns under the water, and you get 2 high tides and 2 low tides a day, roughly, depending on where you live and what the coastline is doing. It is one of the most reliable rhythms on this planet. Sailors have set their lives by it. Fish have set their lives by it. The whole intertidal zone, every crab, every barnacle, every patient heron, every kid who ever found a shell, all of it depends on that rhythm being predictable. The rhythm is no longer predictable. When the moon was one object, its pull on the oceans was clean. Now there are pieces. Big pieces, in slightly different orbits, pulling in slightly different directions, at slightly different times. The tide does not know which one to follow, so it tries to follow all of them. The result, in the first week, is what the people who modeled this kind of thing call tidal chaos. The water along every coastline on Earth begins to behave the way water behaves when too many forces are arguing with it. It rises when it should fall. It falls when it should rise. It stops, in some places, for hours, leaving fish gasping on exposed seafloor. It surges, in other places, miles inland, without warning, because the surge does not come from a storm. The surge comes from the sky. In the first week, every coastal city on Earth learns a new kind of fear. Not the fear of the tsunami, which at least announces itself. The fear of water that has forgotten the rules. I have been in orbit during a storm before. You can see the lightning from up there. It looks like something is thinking inside the clouds. What I saw in the simulation of week 1 was not lightning. It was the entire shape of the coastlines flickering. Land and sea trading places along every shore at once. Boston blinking, Mumbai blinking, Lagos blinking. The lights of the cities going out in patches as the substations flooded. Week 2. The pieces of the moon are now far enough apart that we can name them. The biggest one, the one that holds maybe 60% of the original mass, is still where the moon used to be, more or less. It wobbles. It is not a sphere anymore. It is a lumpy, scarred, half-collapsed thing that the people who study this sort of thing have started calling the core, because they need a word, and core is the kind of word you reach for when you do not want to admit you are scared. The other pieces have spread into a rough disk around Earth. I want you to picture this from space, because from the ground it is hard to see all at once. From up here, where I am, Earth now has a partial ring. Not like Saturn's rings, rougher, dirtier. A broken band of rock and dust and ice that catches the sunlight and throws it back in 1,000 directions. At night, on the ground, the sky is no longer dark. It glows. A pale, dusty arc cuts across it from horizon to horizon, brighter than any moon has ever been. And inside that arc, you can see the larger fragments moving, slowly, like ships. It is, I have to tell you, one of the most beautiful things I have ever seen. I know how this sounds. The moon is breaking and I am telling you it is beautiful. But that is the thing about this universe that I keep running into, the thing I cannot get used to. The worst things in it are often the most beautiful. The thing that kills you, and the thing that takes your breath away are sometimes the same thing, wearing different clothes. Month 1. The debris begins to fall. Not all of it. Most of the ring is stable, or stable enough, locked in orbit by the same physics that kept the moon up there for billions of years. But the smaller pieces, the ones at the edges, the ones whose orbits got nudged the wrong way during the breakup, those start coming down. Slowly at first. A meteor here, a meteor there. The kind of streak you used to make a wish on. Then, more. By the end of month 1, the night sky over every part of Earth is alive with falling light. Some nights, hundreds of streaks an hour. Some nights, thousands. Most of them burn up in the atmosphere, because that is what the atmosphere is for. It is a shield made of air, and most of the time it works. The fragments that make it through are usually small. Pebbles, fist-sized rocks. The kind of thing that punches a hole in a roof and ends up on someone's kitchen table and becomes a story they tell for the rest of their life. But some of the fragments are not small. Day 47. In the simulation I watched, a piece roughly the size of a city block comes down over the South Atlantic. It hits the ocean. The ocean does what oceans do when something the size of a city block falls into them from space. The wave that comes out of that impact is taller than any building anyone has ever built. It reaches the coast of Brazil in a few hours. It reaches the coast of West Africa not long after. The people who modeled this sort of thing had warned by then what to expect. Most of the coasts had been evacuated. Most. Not all. I do not want to dwell on this part. You can imagine it. We all can. We have all seen the footage of waves, and we have all imagined them larger. And the imagination is not far from the truth here. What I will tell you is this. By the end of month 1, every coastline on Earth has been redrawn. Some of them only slightly, some of them completely. Year 1. This is the part I find hardest to talk about, because year 1 is when humans start to do what humans do, which is adapt. We move inland, the ones who can. We build higher. We learn to read the new sky the way our ancestors learned to read the old one. The ring around Earth becomes, in some places, a calendar. Farmers in the high plains of Asia notice that certain bright fragments cross the zenith at the same time each season, and they start planting by them, because the seasons themselves are shifting, and they need something to hold on to. Children born in year 1 will grow up never having seen a single whole moon. They will see the picture in books. They will not understand why their grandparents cry at it. The climate begins to change in ways the models did not fully predict. The moon, the whole moon, used to stabilize Earth's axial tilt. It was a counterweight, not a dramatic one, a quiet one. Without it, Earth's tilt begins to wobble. Not catastrophically, not in year 1, but enough that the seasons start to drift. Summers come a little earlier in some places and a little later in others. Ice that used to form does not. Rain that used to fall does not. Rain that never fell falls. We adapt. We always adapt. It is the thing about us I admire most and worry about most at the same time. We can get used to almost anything, given enough years and enough quiet, and that is both why we survive and why we do not always notice what we lost. This is the part of the story where I want to stop for a moment and tell you something. I have spent a lot of time looking at moons. Our moon, the moons of Jupiter, the moons of Saturn, the little captured rocks that Mars pretends are moons. I have watched them in every kind of light. And the thing I keep coming back to, the thing that I cannot quite get over, is how rare it is for a planet to have a companion like the one we have. Most planets do not. Most planets are alone. They spin through their orbits with nothing close enough to touch them, nothing close enough to pull on their seas, nothing close enough to hang in their sky. Earth has had a companion for as long as Earth has been Earth. We did not earn that. We just got it. A collision 4.5 billion years ago between the young Earth and a body roughly the size of Mars threw enough debris into orbit that some of it gathered over time into the moon. It was an accident, a violent, lucky accident. And every tide, every eclipse, every full moon over every field where two people have ever stood and looked up, every one of those is the long aftermath of that accident. When I think about the moon cracking, what I find myself mourning is not the rock. The rock is just rock. What I mourn is the company. We have been less alone than most planets get to be. That is the thing I do not want us to forget. Alright, let me come back to the science because I owe you the truth about how much of this is real. The good news, and I want to say this clearly, is that the moon is not going to crack tomorrow. Not next year, not in any time frame a human needs to plan for. The moon is geologically quiet. It has small moonquakes, yes. The Apollo missions left seismometers behind, and those seismometers picked up gentle shakes for years afterward, mostly caused by tidal flexing and by the moon slowly cooling. But the moon does not have plate tectonics. It does not have the kind of stored energy that would let it shatter on its own. The scenario I just walked you through requires something to make it crack, a massive impact. A close pass by something we did not see coming. Some piece of physics we do not currently have a reason to expect. The people who study near-Earth objects watch the sky carefully. The catalog of things big enough to do real damage is by now mostly complete for the largest sizes, and none of the ones we have found are on a collision course. That is not a guarantee. We do not see everything. But it is a comfort, and I think we are allowed to take the comforts where we find them. The tidal chaos, the ring, the debris fall, the axial wobble, all of that is what the models say would happen if the moon broke. The models are good. The models are not perfect. The real thing, if it ever happened, would surprise us in ways we cannot predict, because that is what the real thing always does. What I can tell you with certainty is this: the moon is going to leave us. Slowly. It is drifting away from Earth at about 3.5 centimeters per year. In a few billion years, it will be far enough away that there will be no more total solar eclipses. The ring of fire around a perfect black disk that humans have stood under and wept at for all of recorded history, that will be gone. Not because anything broke, just because everything drifts. So tonight, when you go outside, or tomorrow night, or the next clear night you get, I want you to do me a small favor. Look up at the moon. Really look at it. Notice that it is there. Notice the face on it, the one your ancestors gave names to, the seas and the craters and the bright highlands. Notice that it is moving, slowly, away from you, and that one day, long after you and I are both gone, it will be a little smaller in the sky than it is tonight. We got lucky. That is what I keep wanting to say. Out of all the planets we could have been, we got the one with the companion. The one with the tides. The one with the sky that has something in it to look at. Do not waste the looking. If you want to sit with me through another one of these, the next one is about what happens to a planet when its star starts to die, and what the last people on Earth would see in the sky on the final morning. I will see you there.